Ladies and gentlemen, picture a spider dangling from its web, waiting for dinner to arrive. We all know spiders don't see well. They feel the world through the vibrations in their webs, like a fly buzzing when it's caught. But what happens when the prey stops moving? How does a spider find it then? Today, I'm going to tell you about a fascinating experiment from Johns Hopkins University that's shedding light on this mystery, using robotic spiders. Yes, you heard that right. SpiderBots are helping us unravel how spiders might use something like echolocation to track down their next meal. Spiders have this curious habit. When prey gets stuck but isn't moving, they crouch, sometimes bobbing up and down or plucking the web with a leg. It's like they're sending out a signal, trying to figure out where that silent snack is hiding. Scientists have watched this for years, but studying live spiders is tricky. Too many things can change: wind, web tension, the spider's mood. So the team at Johns Hopkins Pterodynamics Lab decided to simplify it. They built robot spiders, stuck them on synthetic webs, and tested a wild idea. Spiders crouch to sense tiny differences in web vibrations, pinpointing prey that's gone still. Here's how they did it. The first SpiderBot wasn't fancy. It couldn't move much, just sat there feeling web vibrations. But then they upgraded it with motors so it could crouch, bobbing up and down like a real spider. It had 4 legs, not 8 like the real thing, with 2 joints each and sensors to detect motion. They also made a prey robot that stayed still most of the time. The web. A clever mix of parachute cords and hair tie cords, mimicking the strong spokes and sticky spirals of a spider's real web, hung right from the ceiling. They ran 2 tests. First, the SpiderBot crouched on an empty web. Then they added the prey robot, which moved just once per test, sometimes weakly, sometimes strongly. High-speed cameras watched everything. Here's what they found. Without crouching, the SpiderBot couldn't find the prey if it wasn't moving or barely twitched. But if the prey made a big move, the SpiderBot spotted it, no crouching needed. When they looked at the vibration data, it got really interesting. The crouching made both robots shake the web, each at its own unique frequency, like 2 different notes in a song. The SpiderBot could tell the prey's frequency apart from its own and even figure out how far away it was. The closer it got, the stronger the prey's shakes. Now the researchers say this isn't exactly echolocation, not like bats bouncing sound waves off walls. The prey doesn't reflect the SpiderBot's vibrations. Instead, the crouching shakes the web and makes the prey wiggle too, creating new ripples for the SpiderBot to sense. It's an analogy, but a brilliant one. They presented these findings today, March 18, 2025, at a big physics summit in Anaheim, California. Why robots? Because animals are unpredictable. You can't ask a spider to crouch on cue. But with a robot, every test is the same, and building it teaches you how the real system works. This team's not new to this. They've made cockroach and fish robots too. For this project, they teamed up with spider experts who study web building and engineers who 3D printed the SpiderBot's flexible joints out of silicone. Together, they're cracking a puzzle nature's kept hidden. So there you have it. Robotic spiders revealing secrets of the real ones, hinting at a kind of echolocation through web vibes. It's a glimpse into how nature and technology can dance together, and it's happening right now, today. Who knew a crouching spider could teach us so much?